everybody. I'm here to talk about how PlanGrid started using Istio, some of the problems that we had along the way that made us look at using service meshes in the first place, and then how we went and implemented various parts of that with no downtime along the way. PlanGrid is a construction productivity app, so our main user is actually somebody in a hard hat and boots on a construction site. We have workflows for making sure they get the right information at the right times and that they always know that they're building the right thing based on the right set of plans. My name is Patrick Auld. I'm a software architect at Autodesk. I was the systems architect at PlanGrid before we got purchased in 2018. I'm really excited to talk to you.
The first project we took on involving Istio only used Ingress. So this is what our architecture looked like back when we did that. We had Akamai here. This gets all of the primary DNS to all of the PlanGrid domains. This goes to elastic load balancers that go to specific services that run inside of Kubernetes. K8s is an abbreviation for Kubernetes. So we have things like app.plangrid.com going to one service and api.plangrid.com going to another service. We also provision additional elastic load balancers. We do these deployed within our VPN at work. These are used by developers, internal tools, some automation, and are generally a way for people to access directly to some services that would not otherwise be publicly accessible. All services get private VPN ELBs. They only get public ones if they need to be accessible on the open internet. An architectural change we made was to enable it so individual feature teams could easily spin up new services instead of having to work within the distributed monolith. This resulted in new teams provisioning things that needed to be accessible definitely within the VPN, and sometimes there were use cases where they did have to make things publicly accessible, and we would put them on public ELBs that went to Akamai. This resulted in a few problems in our infrastructure. One, we had lots of ELBs. More than once we hit the limits in AWS where they would not provision more, and we had to request an increased limit from them. While they did this every time we asked, there was a continuous fear that at some point they wouldn't. The other big problem was Akamai. Management of Akamai was very difficult to do programmatically for us. Their API did not have tool integration with Terraform or the other infrastructural tools we were using. So setting some of these vanity domains on the PlanGrid domain was a manual process that quickly started to fill up our ticket queue and become problematic. The other thing was there was an authentication library used between the two monoliths. When a new service was spun up, it would use the same library, but there could be slight differences in how it implemented or how it used these. This created ergonomic issues because sometimes our web, mobile, and third-party developers would get different response codes for some things than they would expect. And there was always this lingering feel that there was a security issue because somebody had implemented something differently, and it was very hard for us to audit it across the plethora of services that were being created. So let's simplify things a little bit here. So the first project we did specifically targeted the authentication problem. We were looking for a way to authenticate all requests going into our data center centrally so that people could spin up new services and not have to re-implement as a complex authentication logic as we had. At the time, there were 5 different ways to authenticate for 5 different use cases. We evaluated a number of solutions, and what we decided to go with was Istio. This project only used the Istio gateway. We provisioned a new one and gave it an ELB to Akamai as well. We configured this and originally sent no traffic to it. Once this was here, we set routing rules within the service mesh so that if this gateway received any calls to the domain app.plangrid.com, it would go to the correct service, and the same for api.plangrid.com. They would go to the correct service. Once this was set up, we utilized a feature in Akamai to slowly shift traffic over. So now we can start to send 1% of traffic into Istio and the other 99% out. This let us canary all of our changes and very slowly roll them out as we became confident in them. We did this one at a time, but got to a point where eventually we had migrated all of our domains to using the one ELB for Istio. At this point, we could watch the metrics on the remaining ELBs, and when they went down to 0, we could deprovision them. So this solved the problem of public ingress going in. The other side was slightly different. These ELBs we had DNS names directly mapping to. Because these were only used internally, though, and we knew that it was only our teams, internal services that did it. We weren't as concerned about the DNS leakage. So what we decided to do here was spin up an entirely different gateway, give it its own ELB into the VPN. A short one here. Oop. And now what we did was we put a wildcard DNS on this. All of these domains used a standard form of service.environment. And then we had an internal domain. So the way that we did the migration was, with the wildcard in place, we would go to the teams owning the services and tell them we were going to remove the specific DNS entry for their service. This causes DNS to go to the fallback on the wildcard. Once we did that, we would check and watch the traffic on this, which was actually even easier because it was internal. There were no public scanners or anything like that. So the traffic would really go to zero eventually. If anything lingered, we would go talk to those teams and tell them to restart services or make sure DNS refreshed. But then we got to a point where we could deprovision all of those ELBs. So at this point, we have two gateways, one getting all internal traffic and one getting all customer-facing traffic. We actually developed really great dashboards at this point that let teams see all of the error codes, latencies, and responses only going to customers. And a lot of teams made alerts and different integrations with it just off of that from the ingress point of view. This only solved the ELB proliferation by limiting us to these two, though, and it moved the DNS problems that we had in configuring Akamai into configuring Istio. Now the Akamai configuration was very straightforward. Everything always went to the one ELB, and we had integration into our continuous deployment tool to provision not just the Kubernetes manifests that they needed to, but also the Istio manifests, so that any new service that was provisioned was correctly set up with both the internal and the external gateway. To solve the authentication issue, we took the library that was shared between the two monoliths, and we extracted it into its own service. This service, a really long one. So this service, we then made a plugin to Istio that for every request coming in would send to the central authentication service all the headers that were associated with it. The central authentication server could then respond if the request was allowed or not, whether it was authenticated, and any changes to headers. It could delete and add headers, and the plugin would respect that. The central authentication server knew how to check for the different types of authentication things, or knew how to check for the different types of authentication types, and it could, for a given domain and for a regex or a prefix on a path, know if a specific call was or was not allowed to be authenticated. We knew there were customer workflows that required unauthenticated calls to APIs that were otherwise authenticated, so it was critical that we had this allow list that things could get through if they didn't have it. In the beginning, this plugin did modify the headers, but ignored the response whether or not something should or should not be allowed through. This allowed local authentication to happen in all of the services as well, but for us to still pass through the headers that would exist from the central authentication system. At this point, we took the common middleware that was running across all services, and we updated it to instrument the local authentication to tell us how often local authentication and the central authentication would be performed. But we still didn't have it override. It was always falling back to local authentication. With this, we had dashboards, and combined with the logs of the specific calls from central authentication and the plugin, we could start to see which services were not always being correctly handled by the central authentication service, and which ones we did have fully covered. Over time, we worked with teams. We figured out what endpoints did and did not have to be put in the allow list and deny lists. And we ended up at a point where the dashboards essentially went to the local authentication never occurring. When this happened, we turned the plugin over so that it started respecting the deny requests. And now, any request that came in that should be denied according to the central authentication server is, and never makes it to the service at the end of the day. Once that's there, we actually took the local authentication out of the different middleware, and now we're in a place where all requests were authenticated centrally via the one service. This actually works with the other gateway as well, but it's hard to fit. So a big thing that we did in all of this was we really did not want to impact local development. We wanted to make sure teams could continue to iterate and not have to worry about anything we were working on. So we almost did that. We came very close. When we got to the point that we were taking the local authentication out of the middleware, there was an impact that we had. And this was either developers, when they were sending network requests locally, had to add the headers that would be added by the central authentication server, so the middleware knew that they were authenticated. We also added an option inside the services so that it would allow everything that's going through. So when running locally, people didn't have to worry about authentication at all.
So the next project we had was all about observability. We talked about in the first project how once we had all of our traffic going through the private and public gateways, we got really good dashboards that teams started to utilize. This ended up being slightly confusing as we grew. Because these were only metrics captured at Ingress, either from the VPN or from the public internet, it didn't actually give you any data when two services inside this cluster were talking to each other. Also, if you had a service that was called by another one or was even just proxied by another service, as we had when some people broke some of the monolith pieces out, you didn't have metrics that were easy to pull out of that gateway because they would be associated with other services. So the next project we did was essentially all about just adding this destination and source app option to the existing dashboards that we had so people could really start to drill in and see what was going on. The way we did this was to add sidecars. We got to take a step back though, and we're going to talk a little bit about the system we built when we moved out of Heroku. This was entirely Docker based. The contract we have with feature teams is that they give us Docker images and we will deploy them in a Heroku-like experience, and I'm air quoting a lot in this. The way this works in principle is we have these YAML files that people can define what their service looks like and how it should be deployed at runtime. So this is an example for a comment service. I would deploy the Docker image built from the main branch into the prod pipeline, and I would only make it accessible over the ELB that's within the VPN. No need to be public here. What this does is we consume this YAML, and it generates a whole lot of Spinnaker pipelines. So this is an example of one of our more basic ones, actually. There's a lot of options people can put in to build these in, but all of these Spinnaker pipelines are built to take that Docker container, make the pod spec and other Kubernetes necessities around it, and then deploy that into our Kubernetes cluster. So here I've actually highlighted the apply cacahuète manifest. Cacahuète is the name of one of our monoliths. It actually means peanut, it's French. This is a step that we included when we wanted to add Istio support so that we could, before launching a service, apply any routing changes that we needed to make the two gateways work. That was where we said, for these host headers, they're going to go to these services. So we snuck that in. The nice part about all of this is we updated this transparently to teams in almost all conditions. So when we went and did the next project of saying, okay, we want to add sidecars, we did the same iterative approach where we had people opt in. And really all we did was add a new option into this YAML where we could say that they were or were not in the service mesh. In the beginning, everybody was, the default on this was false, and we slowly rolled people out. Eventually we got to a place where we were comfortable and we inverted it, and now the default is true, and you have to explicitly opt out. In doing this, we ran into a whole lot of really interesting things. It was fairly seamless overall, but we did hit a couple of Envoy and Istio issues, specifically around Redis. There was an issue on how SSL and authentication, when combined, worked with Redis that would bite us in the difference between some of our Redis lab deployed Redis instances and our AWS Elasticache deployed Redis instances. And this unfortunately is one of those where we were not totally consistent between environments. So we actually had this soaking in pre-production environments for a while, and we attempted to roll it out in the production environments. We hit one of these scenarios where it was living in a different place than it was before. We had to roll that back. The way we fixed this was we just said that the sidecar could ignore these IPs and it would just pass everything through, or it would not pass everything through. It would ignore these IPs and just let everything go around the sidecar. So we didn't get observability for these pieces, but because it was a known IP space and it was actually an issue that was fixed in a future version of Envoy, we said, okay, we'll just let it go through for now. And then when we upgrade, we'll be able to take this restriction out, let it go. So you can see here what the dashboards look like now. We can actually drill into two services, get all of the different high-level metrics between them. It lets us set things like SLOs and alerts on a per service communication path basis. It has been really, really helpful in some of our incidents for tracking down exactly where hotspots are and where we need to focus our attention.
So up to this point, we've been using an architectural diagram such as this to represent what PlanGrid's systems looked like at the time. For the last story, we actually have to change this a little bit, because the last story is a disaster story. We did not have a situation where the gateway was taking all requests and fanning out to services. We had services that were entirely behind the monolith and were straight proxied through. We'll say for this story, this is the Rails monolith, and the proxy code that here is extremely minimal. It just passes things through and only exists so that all of this can be served over the same domain. What happened is there was a new feature released in a service behind the Rails monolith. This was a feature that was available on the home page, so all users saw it immediately upon logging in, and it had higher latency than most of the other features that we had at the time. Not considerably higher. This actually was okay in initial testing, and we did a slow rollout to users and did not cause any problems. What happened is when we rolled it out to 100% of users, the slight increase in latency ended up consuming all available connections within Rails. This had the effect, because this was the service getting all requests from the web, of taking down the entire website. We identified it pretty quickly. We rolled back the feature that was here. However, this was a feature that was highly requested by users and was a long time coming, so they weren't happy that we pulled it away. What we ended up doing was modeling the domains and the services so that we could now route around this Rails monolith. And because it was just doing a straight proxy, this was fairly simple. So we ended up in a situation where now app.plangrid.com from the gateway would fan out appropriately to these services, and we ended up getting rid of all of the proxy routes out of Rails. We saw a pretty good performance boost when this happened too, because the Rails, it turns out, is not a great proxy.
This project was done in haste as part of a firefighting exercise, essentially. Because of that, we didn't put a lot of time and thought into the modeling of how we were going to do this L7 path-based routing. What came out was a less than ideal situation. Instead of modeling APIs like app.plangrid.com and saying specific routes or prefixes go to specific services, we ended up with a situation where we stole some endpoints from services. This example that you're seeing here is a routes file that was in our service definition, and we would then say for a service, specific routes actually go to different services. This made it so there was still a one-to-one mapping between an endpoint, so app.plangrid.com, to the Rails monolith, but for specific aspects of the Rails monolith that matched some of these things, like here is a prefix, proxy insights, we would send this to the PlanGrid Insights destination, which is the name of one of our services. The really big drawbacks in this is it made it incredibly difficult to decouple the idea of the API from the service, and you had to know that an API mapped to a service and then steal the endpoints from that service. It also made it more confusing because you could go to the PlanGrid Insights service and then put another route in there that would take proxy insights and send it to yet another service. So by not modeling the API in the first place, we really backed ourselves into this corner where it was very difficult to reason about where things were going to go if we open this up. We never expanded this usage beyond the one endpoint that was, or we never expanded this usage beyond the one API that was having the problems. We really took a step back and said we need to do this as a first-class citizen within our system. This brings us to where we are today, where we have first-class representation of APIs and first-class representation of services, and there are relationships that you set between them.
So here's the projects that we talked about today. We never set out to implement a service mesh. All of these were very problem-focused, and we saw a service mesh could help us get over the humps that we had in our production code. I also couldn't get into a lot of the smaller projects that we did along the way that I had to cut for time, but we did things around distributed tracing and a lot of small ergonomic enhancements that really helped out too. Looking forward, I'm not going to talk about all of these, but I want to touch on the first two. The first one is our API modeling. We're seeing that being a system that goes beyond Istio and beyond the service mesh. We want to integrate that into our security systems, into our global load balancing, and other network tools and administrative tools that we have beyond just Istio itself. Really excited about where it can go. The other one is pull request deploys. We want to deploy PRs of backend services into live environments and set routing rules such that only specific users or under certain conditions do people go to the new service to let us get very insightful testing of pre-merged code in live environments. We're also hiring. If you want to come help us fix construction, we would really appreciate it. Construction is one of the only industries on earth that has become less productive over the last 100 years. The efforts we put in here are really going to move the needle and make a big difference for a lot of people in the world. Ping me for any links, referrals, or questions that you have. Been great.